There's three things we want to accomplish in this video segment. We want to develop a methodology for orient ourselves in the Z space so that we can always have the microscope properly tuned to the specimen layer. Second, though, we want to develop a procedure for searching the slide in an economical fashion. And finally, we want to develop a methodology for determining the coordinates of things that we find under the microscope so that we can note those in our laboratory notebook and go back to those same areas in the future. In this segment then, we're going to use the coarse focus knob. We're going to use that, of course, with the lowest power objective only. We're going to use the fine focus knob for both the lowest power objective and other objectives as well. We're going to use the XY translation stage mechanism to move our specimen around and search for objects of interest. And we're also going to use these two scales on the X and the Y, on the abscissa and the ordinate, which we can use to then map areas of interest on our slide. We've got the microscope set on the 4X objective, which gives us a total of 40 power magnification. We've got the slide stage all the way down, and we're going to start slowly raising the stage with the coarse focus knob. Okay, it's coming up. Again, very, very slowly. And the very first thing that's going to come into focus is the cover slip on this particular specimen. So we're actually going to see the thin glass layer plus anything that's on top of that before we actually see our specimen. Still coming up here. Now, as this comes into focus, you'll notice that there's some grit on the top of the cover slip. I'm going to move the stage just a little bit, and I'm going to reposition things. You can see two paramecium on this slide, which are slightly out of focus, and that's because we're currently focused above the plane of the specimen and looking at the top of the slide. Now, from this point on, I'm only going to use the fine focus. I'm not going to go near the coarse focus again. So there you can see the top of the slide, and as I move the stage up a little bit more, you'll see the specimen layer come in and out of focus. Now, if I continue all the way down, we can actually see the bottom of the microscope slide, which is right about there. And again, if I just move a little bit, you'll see some artifacts that are present on the bottom of the slide. Then we're going to come back up here to our specimen layer. Now that we've oriented the microscope in the Z dimension, up and down, we want to look at a search pattern. I always start my searches on microscope slides in the upper left-hand corner, but you should follow whatever protocol is in your laboratory. What you're looking at now is the edge of a round cover slip, and there's a couple of paramecium that are near the edge. And what we're going to do then is we're going to start our search pattern here. So we're going to move to the across the slide, and there you can see a couple more parameciums, and now we're on the edge. We're going to move down, we're going to move across again, okay, down a bit, cross back over, down, over. And as you can see from the edge of the cover slip, we're getting very close to the bottom edge of this particular specimen. And down and over again. Alright, one last pass and we'll have mapped the entire slide. There you can see actually a couple of paramecium that are outside the cover slip in the embedding media coming out of the bottom of the cover slip. We're going to center it as best we can, and then we're going to move the objective turret to the next lens, which is a 10x, and this will give us 100 power. See that the image is a little bit blurry, so we'll use the fine focus knob to enhance the image. We're going to recenter it, and now we're going to move to the 40 power objective, which is this one, and again using the fine focus only, we're going to move in for sharp detail and then recenter it. That gives us a nice close-up view of the nucleus. And if we focus up and down a little bit, we can just barely see the cilia on the outer membrane of this particular cell. Now if we want to, we can record an image or we can record the coordinates of it, and I'll explain that in just a minute. If we want to continue searching, then we go back to the 10x, quick focus, back to the 4x, quick focus, and continue our search pattern. Okay, if there's another one there that looks like it might be a good specimen. There's a paramecium right there that looks like it might be a little bit better specimen. It's lined up a little bit more horizontally for taking an image. Okay, so we move from the 4x, the 4 power, to the 10 power, from 40 to 100 power, and then we drill down with the highest magnification and carefully center it. Now we can see the vacuole in there pretty good off to the left-hand side. We can see a little bit of glow of the cilia around the edges, and of course the prominent nucleus and the nucleolus in that particular cell. Now we might actually want to adjust a little bit of the light parameters and see if we can sharpen or get a little bit better contrast inside of our specimen. We wouldn't want to move the substage condenser very much, but we can of course tweak the substage condenser iris in order to get a little bit more contrast. And we'll do that now. And then add a little bit of light with the rheostat. And there we get a little bit better clarity. We can see a lot more vacuoles now. We can see the nucleus, the nucleolus. Okay. Now the X and the Y scales on a microscope are brand specific, and very often they're even model specific. The coordinates are not going to be able to translate very well to a different microscope in absolute terms. However, in relative terms, they're still very useful. If you know that a particular object is so many clicks over and so many clicks down, you'll be able to find it quickly even on a different microscope with slightly different scales.